G'day General Math students. In this video we're going to learn the steps that we need to perform in order to obtain a linear regression on paper. So in previous videos we've learnt how to obtain a linear regression for some data using the calculator. So in this video we're doing it the old-fashioned way. So let's get to it. Now I've got to introduce some mathematical notation here. This sigma, Greek letter sigma, which in the context of mathematics represents sum. Basically it's saying add them all up. So for instance, if we were to add all of these numbers which represent the x variable, so I'm just going to put an x here, all right, we should get, if we put them all into the calculator, 202. So go ahead and check that. Pause the video and check that if you're so inclined. So we're summing up all those numbers. So here we have the sum of x, which will be important for our calculations later. We need that. You might want to pause the video now and find the sum of y, the textbook sold, the y variable. I'll let you do that, then I'll write down my answer. Okay, so when I added those up on the calculator, the sum of y, the y variable, textbook sold, was 203. So in this context, what we're looking at is these variables: enrolments. What have we got? The number of economic textbooks sold each year compared to the number of students who enroll in the economics class. So we're expecting if there's more students, there'll be more textbooks sold. Not everyone's buying the textbook, but or the textbooks, but that's okay. Here's a scatter plot of that data, and we're showing that there appears to be a positive correlation here as well, as we'd expect. More people, more students means more textbooks being sold. But the focus of this video really is on obtaining the linear regression. You'll need to look at previous video on scatterplot if you're unsure how to do that. So now what we need to do is complete the rest of this table. So we need the values, these sums, because you can see down below, for instance, we need these sums in order to find the gradient and the y-intercept of our regression. For instance, the sum of x, which we found here, you can see that that appears in the equation here and here. So we've got that value. And the sum of y, which we have over here, that appears here and here. And I missed one of the x's, the sum of x, which appears there as well, so I'll mark that one in. So you can see that we've got some of the values that we need so far, but we also need to complete the table to get the other sums that we need that go into these formulae. So for this next column, I'll go with this purple type colour. So for this one here, bluey colour, we need to multiply x by y. So that means, for instance, for this first row here, oops, trying to rub that out. For this first row, we're going to multiply 20 by 25. Okay, so 20 times 25 gives 500. So we're going to write the number 500 here. And then in the next entry, it's going to be 32 times 36, and so forth, all the way down. So pause the video, you go ahead and work out those values, and then I'll write down the values that I got. Okay, so if you're ready, I'll write down the values I got. So 32 times 36, we get 1,152. And these other values as we go along. This is what you should have. And 1254 at the end there. This here was meant to be a 9. I'll just neaten that up a little. Righto. So that column is complete, and we need to sum those. So because this is our x by y column, this is the sum of x times y. Okay, and that is equal to 7138. So now we have the sum of x by y, which is going to go here. And that's the only spot by the look of it. Okay, now we're going to square the x value. So square each of these enrolments. So the first one is 20, and I square that and it will give us 400. Alright, so I'll write that down in the table. This is 400. Okay, so go ahead, pause the video and square each of the other x values now and see what you get. Then I'll do it. Alright, so the rest of them should be this. 676 and 1444. Alright, and then we want the sum of x squared. We're going to sum this column. And we get 7250. Alright, so I'll go a grey type highlighter this time. Alright, so that sum of x squared needs to go here. And that's the only spot. Now just a quick note how it's interesting. I just want you to focus on these two at the bottom here and how they are actually different. Alright, so the one that I've highlighted grey is the sum of all the x values squared, whereas this one, because it's in brackets, that means we need to take the sum of x, this green highlighted value, and square that. Okay, so that could be a bit confusing, but those are different, right? So this equation here will give us the gradient of our regression line. So we'll work that out shortly. This equation here will give us the y-intercept of our regression. So let's go ahead and work those out. I mean, you might want to pause the video right now and see if you can plug in all the numbers in the right spots and also identify what the n value should be. So these n's here, I haven't explained that yet, but see if you can just determine what the value of n is. But then in a few moments I'll show you the substitutions, and if you're not sure you can just wait till that point and work it out on the calculator then. But I'll give you that opportunity to pause and see if you can work out the gradient and the y-intercept. Okay, I'm going to forge ahead here. So the gradient. So the n value is the number of scores. Okay, now of course there are 12 scores if we add up all the x's and all the y's, but we're talking about purely how many data entries there are, and there are actually 6. Okay, so there were 6, I suppose, bivariate data type scores. Right, so it's basically, if you count the number of rows, we've got 1, 2, 3, 4, 5, 6 rows, so 6 data entries. That's where we get our n value from. Alright, so 6 pairs of data maybe is a better way to put it. So we're going to put a 6 where the n goes. Alright, so I'll just make a note here, n equals 6. And then the sum of x times y, well that's the 7138, so we multiply, then we subtract the sum of x, which is 202, multiplied by the sum of y, which is 203. Alright, so I'll just do a little bit of highlighting just to line things up. So that's the sum of y, which was highlighted at the purple, the sum of x, which is highlighted green. The sum of x times y, which is highlighted in the blue. Alright, and then we divide by 6 for n, multiplied by x squared, which is the one highlighted grey. Alright, and we subtract the sum of x, but that needs to be squared. So that's different. This is sum of x squared. So I've got to square that value there. Just make it so it looks like you can see that a bit more clearly. So we're going to square that. Okay, so if we put this into the calculator, I'm going to use this fraction button here. All right, 6 times 7138 minus 202 by 203 over 6 times 7250 minus 202, and I'll square that. Just got to convert that to a decimal. So I'm going to go to say 4 decimal places on this. Encompass quite a few decimal places. We'll go to 4, 0.6758. And that's the gradient of our line. All right, so for the y-intercept, slightly less complex formula. We've got the sum of y, which is our 203, minus a, so that's the gradient. That's what we just found here. So I'll better highlight that with another colour. Okay, so there's our, I'll go with this darker blue. That a there comes from this value we just calculated for the gradient. So 0.6758 times the sum of x, which was 202, divided by n, the number of scores, 6. We'll do a little bit of highlighting so we know where it all comes from. And the 202 there. Alright, so when we put that into the calculator, what do we get? 203 minus 0.6758 times 202 on 6 gives us 11.0814. 11.0814. I just forgot that. Okay, so that is our y-intercept of the equation. Alright, so you should know by now how to write down the equation of this line. Go ahead, pause the video, see if you can write down this as an equation. Okay, I'm going to do it now. So our general equation for a straight line is that y is equal to the gradient times x plus the y-intercept. So our equation will look like this. Y equals 0.6758 x plus 11.0814. I suppose, you know, we could sort of use different letters rather than y and x. You could say have T for textbooks sold and E for enrolments or something like that, but I'm just going to leave it like this time because they haven't given us any particular letters to use. So just 2 quick things to do here. We've got to plot this line on the graph here. So in order to do that, we're going to pick a couple of x values and substitute those into the equation. All right, so I'll put x equals 20, doesn't have to be that, and I'll put x equals 40. And substitute those into the equation and see what we get. You might want to pause the video and try that and then see if you know how to plot the line based on that. I'll give you a chance to pause. Okay, I'm going to do it. So it's y equals 0.6758 by 20 plus 11.0814, and y equals 0.6758 by 40. Now we didn't have to choose 20 and 40. It really doesn't matter what x values you choose, so long as they're on the graph as such. Like what I mean there is, you know, as long as they're on this axis somewhere, you could choose any two x values. They don't have to be original data points or anything like that. Okay, so what do we get here? So 0.6758 times 20 plus 11.0814 gives 24.59. So we say 24.6. I know I've been going to 4 decimal places, but we'll just sort of go to a 1 decimal place on this one. That's good enough. 24.6. And the second one will be 0.6758 by 40 plus 11.0814, 38.1. Okay. So this has given us 2 coordinate points now that we can plot. I'll switch to a red pen for this. So the first coordinate point is 20 and 24.6. So 20 for the x value and 22 for 24. Can go about there. So 20 and 24.6. Okay, so that's one coordinate point on our regression line. And the other coordinate point is 40 and 38.1. So 40 and 38 is here, so about, say, there. 40 and 38.1. And now we can rule a line through those 2 points. And that'll be it. Have a look at what that looks. There it is. Okay, so just sort of missed that there, but I really want that to go through that, both those dots, but I might just have one more go, seeing as the computer can rub it out pretty quickly. So, the last thing we're going to do, I might just leave that as it was. So the last thing that we're going to do is check this on this regression on the calculator, right? So I'll leave that line. We're just that's meant to go through that dot there, but it's close enough, we'll say. Okay, now the calculator. You always have access to the calculator in this course, so you can always check your regression calculation to see if you've got it right. Okay, if you're doing it on paper. This, once again, this is a subject of another video, is how to get to this point to obtain a regression on the calculator. So if you're not sure with that, make sure you go back and look at that video. But from here, I'm just going to go Menu, Statistics, Stat Calculations, and this linear regression number 3, mx plus b. We'll input x and y. I'll just use x and y for the variables there. It's explained in that other video. Okay, and we can see here our gradient and y-intercept are identified for us over here, m and b, and they match what we got on paper before. I suppose the y-intercept is slightly different. That must be noted. that is due to the rounding that would have been used. You know, we went to 4 decimal places here, so it has had a slight effect on that number there, but aside from that, it matches up. So yeah, with the rounding off, it will have a slight effect, but we can tell from this that we've done it correctly on paper. Okay, so thanks for watching the video. Go ahead and practice that process so that you know how to do these ones on paper, and check them against the calculator as well.